In this exercise video, we'll walk through the quantity takeoff calculations for the different work scopes involved in constructing a concrete drainage channel. Heads up here, this is a long exercise. The channel is 9,500 feet long and its depth changes from 18 feet at one end to 10 feet at the other end. The channel is constructed in segments of 50 feet each. We start by calculating the first quantity, the concrete volumes. We will differentiate between two volumes for two different concrete placements, the slab and the walls. They are constructed separately using different construction methods, and we need to calculate their volumes separately. We calculate the slab volume by multiplying the cross-section area and the length. I will leave it to you to match the values we use in the calculation with the dimensions on the cross-section view. The wall volume follows a similar process, but you see here that we are taking the average of the cross-section width and height. The height is different over the channel length, while the width is different within the cross-section between its top and bottom. The second quantity we will calculate is for the formwork of the slab, walls, and their bulkheads at the cross-section faces between the different segments. For each formwork element, we will calculate two quantities, the erection stripping quantity and the fabrication. The following calculations we will need to examine both the cross-section and longitudinal sections. We will start by first calculating the E and S quantities. For the slab formwork E and S, we are dealing with only two sides of forms for the length of the channel. For the walls, we are dealing with two faces of the two walls. One of the faces is straight vertical, while the other face is at an angle alpha that I calculated to be able to calculate the true sloped area of the formwork. The bulkheads are needed at the cross-sectional faces at the start and end of each channel segment. So we end up with 191 bulkheads when the whole channel length of 9,500 feet is built in 50 feet segments. So the bulkheads for the slabs and walls are calculated as shown. The formwork fabrication quantity will be dependent on the E and S quantities and the number of formwork uses between the different concrete pours. We have seen this table in the lesson video, which provides some suggested use values of the formwork for different structural elements. For slab formwork, we will assume it is used 10 times. So we'll need only to fabricate 4,750 square feet to be erected and dismantled 10 times to cover the total required area. For the walls, the formwork is assumed to be used for 20 times, as the wall surface area is larger and results in less fabrication waste. The bulkheads will result in the least uses of formwork, so we'll need almost a third of the E and S area to be fabricated. The next quantity is the fine grade finish under the foundation, which is that simple footprint area of the slab. Next, we need to calculate the quantity of the horizontal construction joint between the slab and the walls, as they need to be sandblasted. The wet finished area include the horizontal top surfaces of the placed concrete that's not finished by the formwork and needs screeding, floating, and troweling. For the slab, we are excluding the joint area with the wall, as there is no need to have a smooth finish to it. For walls, it's that little top area. For cure areas, we will consider all faces of the finished concrete except for the bottom face of the slab that's not in direct contact with air. For dry surface finishing, we will differentiate between the different surfaces that are exposed and not exposed to the eye after the structure is finished. The non-exposed areas include the slab sides and wall outside surfaces, as they will be hidden after the soil is backfilled around the channel. The formed surfaces that will be exposed only include the inside faces of the walls. The lost quantity we will calculate as for any miscellaneous items that are embedded in the concrete. In this example, we have only the water stops that run longitudinally to stop the water to leak through the wall slab joint, or run transverse to stop the water from leaking through the joint between the successive channel segments. We can calculate their linear quantities as shown. Wow, that was a long exercise of quantity takeoff calculations. I hope now you appreciate the work of trade specialty contractors who account for all little details that are involved in their work scopes.